Hello class, and welcome to Algebra 1 this year. The first unit of study in Algebra 1 is predominantly review, but these videos are available for you if you need a little extra help already. And as always, please let your teacher know as soon as possible if you are having trouble with the material so we can give you some extra guidance and help during class or during the school day as well. Today we're going to focus on, first off, opposites and absolute value. All right, if you already remember this, that's great. You may not need to watch this video, but again, if you need a little bit more review or if you missed class, this could definitely get you back to where you need to be. First thing we want to talk about in this section is the idea of what we call additive inverses. Additive inverses. Additive, obviously you're going to think of addition. Inverses, if you don't remember that word, inverses is definitely what we want to consider the same as being opposite. All right, so that's what we want to fill in here. Two numbers whose sum is, well, if you think of opposite, you're also always going to get an answer of 0 when you add additive inverses together. And therefore, we can also right away go ahead and fill in the next sentence. A synonym for additive inverse is what we just said, opposite. So reviewing these two ideas, let's go through just a quick list of some examples of finding the additive inverse. When you are asked to find the additive inverse, what we're talking about here is what is the opposite, or if you like the first definition we gave, what number can we add to the given number to get a result of 0? So thinking with letter A, we have a positive 3. So just take a second. What can I add to a positive 3 to get an answer of 0? That would be the opposite of 3, or negative 3. You're going to find that negative and opposite are indeed the same. What about letter B, 0? This is a little tricky. What can we add to 0 to indeed get an answer of 0? Well, some people may say negative 0. But really, the opposite of 0 is just itself. Negative 0 is still a 0. So that one can be a little tricky. Letter C, negative 2.5. If I want to make that be a 0, I'm going to add a positive 2.5. Positive 1/2, we're going to add a negative 1/2. Positive y, a lot of times people will call this a negative y. Later on, you're going to want to consider that more as the opposite of y instead of a negative y. But for now, if you like to call it negative y, that is not wrong. So hopefully you're seeing the pattern here. A negative 2z, that's going to be a positive 2z. Negative 5.22 plus 5.22 gives me 0. Letter H, we would need a positive 7/4. Letter I, a negative 140. And for letter J, that is supposed to be a pi value. And the opposite of pi would be negative pi, or we could read that as the opposite of pi as well. So again, real quick review on opposites. With opposites, again, the whole point is you want to focus on the sign in front of the value. If you're given a positive, then the opposite would be the negative, and vice versa. Okay, the last topic for the review, absolute value. Absolute value, some of you may remember this, some of you may not. Okay, if not, here we have a quick little reminder. Absolute value is talking about a number's distance from 0 on the number line. It is shown by the parallel bars that you see in this first example. Those two parallel bars are the mathematical way of asking what is the absolute value of negative 3. Well, if you think of a number line, and we can draw a little number line underneath here. You can easily see that they've given us a -3. In order to get back to the 0, we need to move 1, 2, 3 times in order to get to that 0. Therefore, the distance of -3 from 0 is 3 spaces. If we go over to 1,600, right, obviously you don't want to write a number line for that, but hopefully you could visualize that 1,600, in order for you to get back to 0, you would have to move 1,600 times on that number line. Absolute value can be used in a problem. Here we have the absolute value of -6. Well, we know that that is 6 spaces away from 0. Absolute value of 5, that's 5 spaces away from 0. And now use your addition sign to combine them to get you an answer of 11. Absolute value bars can also be used as parentheses, and we'll talk more about this in a future lesson. With the absolute value bars being surrounded by an entire problem of sorts, we would first want to combine the -6 and +5. That gives us a -1. And then consider the absolute value bars. We get an answer of 1, because -1 is 1 space away from 0. So the really big thing you need to remember and keep in mind with absolute value is in our center square here. Absolute value must always be, well, take a look at what we've gotten in our 4 problems here. We got 3, we got 1,600, we got 1, and we got 6 and 5 when we did our absolute value. What do all of those answers have in common? They are greater than or equal to 0. So in other words, answer to an absolute value problem is always going to be a positive value because we're asking for a distance, and distance has to be positive. Okay, so that's the quick little review of opposites and absolute value. If you have further questions on either of these concepts, please make sure you see your teacher as soon as possible so we can get you squared away and back to where you need to be. Have a great day.